Your homework tonight is to complete some problem sets in your textbook on page 6. There are some problems, numbers 4 through 16 even, and all of those right here, probably the best way to deal with them is to complete a table of values. So make a table of values. 4 and 6, you have a table to complete right here. And the rest of them, 8 all the way down to 16, you have to make your own table, and then the instructions ask you to graph the function and compare the graph with the graph of y equals x squared. The second part of your homework, you're asked to graph and think about using the vertex and the axis of symmetry, and I'll put those in a second video. So I'm going to do a couple of just the problems 4 through 16, but know that there's another video that you could watch to look at these problems here. So the next set, I think, is like 19, 20, 25, 27, and then we're going to go to another page. So I'll put all of these in the next video. All right. So let's take a look at one of the table of values problems. We'll try number 8 to start off with. So number 8 gives us this equation, y equals 5x squared, and we're going to make a table of values. The book has a table of values going sideways, right? Here's your x and here's your y. I'm used to making them vertically, but really either way will work, and you of course can choose what works best for you. And I'm going to pick some values that are pretty easy to plug into 5x squared and not get really too big. Like if I plug in 30, I'm going to have to go 30 times 30 times 5, way too big for me. So I'm going to pick some small numbers, maybe -2, -1, 0, and then I want to pick some positive numbers, so 1 and 2, and that ought to give me a pretty good idea of the shape of the graph, some good points to graph. To get the other values, so to get my y values, because I want to come up with a bunch of points, right, a bunch of points to graph, I need to replace my x values one at a time into the equation of the function. So let's do it. 5 times -2 squared, so I'm plugging in x equals -2 first. And then I want to remember order of operation, and order of operation says square things, so deal with the exponents before you multiply. So this becomes 5 times a positive 4, right? -2 times a -2 is a positive 4. And 5 times 4 is 20. So when x equals -2, y equals 20. Already a kind of largish number. I'm glad I wasn't using 30. Let's do -1. 5 times -1 squared. -1 times -1 is a positive 1. So 5 times positive 1 is 5. So when x is -1, y is 5. And let's try 0 now. So 5 times 0 squared, well that's easy. 0 squared is just 0, and 5 times 0 is also 0. So 0, when x is 0, y is 0. And then we'll try the other ones here. 5 times 1 squared. 1 squared is 1. 1 times 5 is 5. And we'll finish it up with 2, although you probably can see where this is going. So the last one I'm going to do 2 squared, multiply that times 5. 2 times 2 is 4. And 5 times 4 is 20. So when x is 2, y is 20. Now I have a great list of values that I can graph. So let's get a piece of graph paper up here. Need to view, a grid. All right. So I'm going to make a little XY axis. And then I'll go ahead and plot those points. And maybe because my y's are going up by 20, or by going into the 20s, I'm going to go up by 5. So make this 5, 10, 15, 20. So this is a 10, and that's a 20. Oh, where did everything go here? Try that again. So 5, 10, 15, 20. Going up by 5s, and then negative 5, 10, 15, negative 20. 5, 10, 15, 20, 5, 10, 15, negative 15, negative 20 on either side. All right, let's plot those points. So my first point is negative 2, positive 20. Change colors here so you can see what I'm doing. I'm going to go left 2, so about there is about where 2 is, up 25, 10, 15, 20. And then negative 1, 5, so negative 1, 5. 0, 0 is right at the origin, and then 1, 5, and positive 2, 20, and then I'll connect them. So I've graphed the parabola. That's part 1, graph the parabola. Graph the function. I did that. And now I want to compare the graph with the graph of y equals x squared. Well, you'll probably remember from class that y equals x squared looks, the table anyways, looks like this. Y equals x squared. So when x is negative 2, y is 4. When x is negative 1, y is 1. They're both 0, and then the values repeat themselves on the positive side. So 1 squared is 1, 2 squared is 4. And if I plot those, and I'll plot them in a different color, make those green, 0, 0, 1, 1, 4, 4. My parent function, remember parent function are the simplest versions of our parabolas. Y equals x squared. It's a little bit, this particular function, the one in black, is a little skinnier than y equals x squared. So the second half of the question asked me to compare it, and I would say the graph is more closed than y equals x squared. So this would be the second half of what I'm asked to do. So graph and then a comparison. And I'm graphing this time by creating a table of values. Let's do one more. Let's do one that's a little tricky looking. Let's see, 8, 10 squared, that looks pretty easy. 12, that's got a fraction and that looks kind of scary. 14, 16, let's do 18. It's got that fraction and we're squaring and we're subtracting. That looks kind of complicated. So let's do 18 next. So number 18. Number 18 is asking us to graph g of x equals negative 1/5 x squared minus 2. So first of all, don't get freaked out by that g of x thing. That's just the just another word for, or another way to write the y-axis. So it's the output the out part of the function. So instead of writing y, we're writing g of x. Not a big deal. We're going to do everything exactly the same. We'll still make a table of values, but instead of y, we're going to write g of x, and how you say that is g of x. And then we're going to plug in a bunch of values. Let's see, what should we do? Pick some relatively small numbers. You can try to do things that are divisible by 5 and get even numbers if you want, but I think I'm going to just stick with small numbers. -2, -1, 0, 1, and 2. It means I'm going to have some fractions to graph, but they're really not that bad, and we'll do some guesstimating if we need to when we get to plotting the points. All right, so I've picked some points or some x values. I need to get some g of x values next, and I'll do it the same way I did the other problem. I'm just going to substitute each one of these x values into my equation. So -1/5 times -2 squared minus 2. So that'll be my first value. When x is -2, I want to find g of x. Remember, order of operation says a square, then multiply, then add or subtract. So -2 squared is 4. 4 times a -1/5. If I write that as -1/5 times 4 over 1, I get -4/5. And then I'm subtracting 2 from all of this still, right? So -4/5 minus 2 is going to be a -2 4/5. So when x is -2, g of x is a -2 4/5. And if the fractions are freaking you out a little bit, stop this video, back up, and listen to what I'm doing again, and see if you can figure this piece out here. If not, make sure you're asking me or Miss M tomorrow in class. Let's try -1. So -1, we're plugging that in. -1/5 times -1 squared minus 2. So -1 squared is a positive 1. 1 times a -1/5 is a -1/5. And -1/5 minus 2 is a -2 1/5. So when x is -1, g of x is going to be a -2 1/5. Let's do another one. How about 0? Oh, this one will be really easy. -1/5 times 0 squared minus 2. So 0 squared is just 0 times -1/5 is 0, and now I've got 0 minus 2, and 0 minus 2 is -2. So when x is 0, g of x is -2, and we're getting really close now. -1/5 times 1 squared minus 2, and you can see I'm going to get the same answer as I did up here. 1 squared is just 1. 1/5 times a -1/5 is a -1/5. -1/5 minus 2 is still a -2 1/5. So when x is 1, y is a -2 1/5. And when I plug in 2, I'm going to get the same answer as I got up here, because that squaring cancels out the negative. Negative times a negative is a positive. So I'm going to get the same value for positive 2, a -2 4/5. So now I have my table of values. I want to graph them. Maybe I will zoom out a little bit so I can see my table while I'm graphing. All right, so here's a set of axes. And if this is my x-axis, the vertical axis is going to be my g of x axis. Now let's go ahead and graph each one of those points. We'll use blue. So -2 to the left 2, down 2 4/5. So I'm going to go down 2 and almost all the way to 3. -1, -2 1/5. So I'm going to go down 1, to the left 1 and then down 2 and just a little bit past 2. 0, -2, so 0, -2. And then 1, -2 1/5. 2, -2 and 4/5. So here's my sketch of my parabola. So that's part 1, graph the parabola. Part 2 says to compare this to our parent function, and our parent function is y equals x squared. Well, y equals x squared, remember that was 0, 1, 1, 2, 4, -1, 1, -2, -4. Here's the parabola. That is the graph of y equals x squared. So how are these two graphs different? Well, there are two things that are different about this one. So in this case, my graph of g of x, -1/5 x squared minus 2. Two things are different. First of all, the function is, the graph is opening a little bit wider, so it's the graph is more open, but also it's flipped upside down, and it opens down. So that's my comparison of the two graphs. And you're going to do the rest just like that. You make a table of values first. Remember to use order of operation. Pick some values. I'm picking -2 up to +2. Those seem to work pretty well. Plug them into the formula. Get the list of y values. Put them on a graph. And then compare the graph to the parent function y equals x squared. Is it more open? Is it more closed? Is it flipped upside down instead of right side up? All those kinds of things. So I'm going to finish this video, and then if you'd like to see how to graph them using the vertex and the axis of symmetry, then watch the next video.